Hello Internet, my name is Quinn and this is Blondihacks. I'm working on the Pennsylvania A3 switcher locomotive this week and I'm excited because I'm going to build the water hatch. That may not sound like an exciting thing, but it's a thing that moves and it's a detail part, both of which I love, especially the things that move part. It's been months since I've made anything on this project that isn't sheet metal or various other stationary structures, so I'm really excited to get into some stuff that moves around, even if it is just one thing that moves. Look, I'm excited, all right? Let's go. Here's our tender so far. Now let's set about filling this giant square hole in the top. This is where the manhole slash fill hatch goes. There's a sandwich of flanges that go in the center, and then sitting in the middle of this panel is a small tower-like structure that has a lid on it that's for filling up the water. I'm going to start by making the fill panel and the mounting flange that holds it in position in that big square hole. I've got a couple of offcuts from previous pieces of the tender, which are just the perfect size for these. So, as usual, I will rough cut them on the bandsaw and then set them up in the milling machine and square up all the edges. There's lots and lots of this type of thing on this tender. So many sheet metal pieces to rough cut and square up on the mill. It's pretty hard to make interesting video when you're doing the same things over and over again. You can get a sense of what I'm building now. The smaller piece is the fill panel that sits on top, and then the larger piece is a flange that goes around the rim of that hole, and it has a square opening in it, minus these little angle cuts in the corners that are for mounting screws. Since it's mostly a square hole, I'm going to set it up with a milling cutter and mill out the center portion. When I get close to those kind of mitered corner areas, then I etch-a-sketch my way around, manipulating both hand wheels and just staying well clear of the scribe line to make sure that I can file down to the line and I'm not cutting into it, which is very likely because I was never very good at etch-a-sketches. I was much more of a light bright and woolly willy type of person myself. Cutting out that center section did require indicating the piece square and edge finding to find the center of it to get the dimensions of that cutout correct. So since I've done all that work, I might as well also drill some of the holes that this flange needs. In fact, it needs a whole lot of holes. There are 8 holes that hold the flange to the tender from the underside, and then there's 2 holes in those corner flange areas for holding the top panel down. Next, it's over to the die filer to clean up those etch-a-sketch cuts in the corners and bring those down to my scribe lines. There's no critical dimensions or anything on these flange areas, I'm just cleaning them up to make them look nice, and we want to make sure that the upper corners of the fill panel are nicely supported when the panel is installed. You'll see how it all fits together here momentarily. If you're wondering how that large panel is held in place with only 2 screws in those top flange corners, it's because the bottom is held in with a tab, which is trapezoidal in shape and fits into a trapezoidal hole that's in this mounting flange. To do that, I'm going to use the fret saw. I fished the saw blade into the piece, and I'm rough cutting to the scribe lines that I've drawn for this trapezoidal shape. This is a very rough cut to begin with, and then I cleaned it up once again on the die filer. Here's the finished piece, the mounting flange that sits inside. You can see all of the features that I just talked about there. Now let's get this thing installed. I need to figure out where the mounting holes in the tender need to go in order to screw this thing into place. So the goal is to get an even looking reveal all the way around the inside of the hole. I then scribed that reveal, flipped the piece over, lined up that scribe line on the inside of the hole, and then used the clearance drill size in a pin vise to mark all 8 of these holes. Since I can't drill these from the inside where the screws are going to be mounted, I needed to transfer the hole pattern to the outside, even though the reveal needed to be calculated from the inside. I hope that made sense. The piece is sufficiently symmetrical because it was done on the mill, so flipping it over like that was not a problem. Then all 8 of those holes are drilled and tapped into the top plate so we can screw this flange into position. All these little screws around the top, like these areas, don't have to be watertight since people keep asking about that. This thing is a water tank that sits upright and level its entire life and there's no pressure in it, so these little 080 screws around the top are not going to leak. Besides, the water fill hatch, which is quite large, is not even sealed. Now I can mount the flange in from underneath The screws are overly long for now, but they'll get trimmed and filed flat later on. So there is the final flange installed. You can see how that's going to work now. It's a pretty nice looking little piece. And the next step then is to get the panel to fill in and sit on top of this. I've cut it to size on the mill, but it needs to be a very, very close fit, and it needs to sit perfectly flush in this hole. And of course the corners need to be rounded because the opening in the tender has corner radii in it from the end mill. It's just a metric scooch too big, which is good because that means I can gently file it down to fit perfectly in the hole. That's really what I was hoping for. I think I cheated it a little bit oversized on the mill to make sure that happened so that I could file it down. And then filing the small corner radii on there was pretty easy to do. I took my time with this to make sure I had as good a fit as I could manage because this piece is going to be visible for the life of the tender, and the better this fit is, the better the tender is going to look. And well, at the risk of tooting my own horn, I gotta say that fit is pretty darn great. I don't know, maybe after 10 years of doing this I'm finally getting better at it, but that is one of the best fits I've ever achieved. Certainly the best fit I've ever achieved straight off of a file. Let's take another look at that because it's so awesome. I feel like I finally got something that fit the way Kozo expects you to get everything to fit. I can just barely push that in and it's flush all the way around. I think that is going to look really nice. This panel needs a bunch of holes in it, and most notably a giant one for the fill hatch, but I'm going to make the fill hatch first before I cut any holes, because I want to be able to transfer most of the holes from the fill hatch. The fill hatch is going to be a largely handmade piece, and I don't expect the hole patterns or anything else to line up all that well on it. I'm going to start by rolling a tube that'll form the cylinder of the hatch. Rough cut and mill, per usual. This piece is a little bit too small for my slip roll, so I'm going to hammer form it. So for that I'm going to need a mandrel. I grabbed a piece of aluminum from the scrap bin, faced off the end, as is tradition. See, I still say that one too. And then turned it down to the ID that I need for my final cylinder. Most of the hammer forming on this project so far has all been in copper, and for that you can make your hammer form the exact size of the interior of the piece because annealed copper has essentially zero spring back. Now annealed brass does have more spring back than that, but it's still pretty low, so I'm going to turn this mandrel to actual size and we'll see how it goes. If there is too much spring back in the brass, then I can turn this down a little bit more. A nice square shoulder on a hammer forming mandrel is also great. It makes it really easy to keep the piece square as you hammer form it. So then I clamp one edge of the material to the mandrel and I start tapping it around. Again, the piece has been annealed to start with. I ended up annealing it once during this process, right at the end. I couldn't quite get it to close up tightly, so I did anneal it one more time. As you're hammer forming, the material work hardens, and so it'll get springier and springier as you go. And this happens noticeably quicker with brass than it does with copper, so you have to stop and re-anneal the piece at some point. After a second annealing, I set it up one more time on my mandrel to tighten up that curve and get that gap as tight as possible. If I did the math right on the length, that gap should close all the way up. And it's looking very good. Looks like I'm very close, if not right there. Ideally, when you're done, the piece will be sitting in its correct final shape with no spring back and no pressure applied. I didn't quite get there. It's got a little bit of spring in it, but not enough that it was worth turning down the mandrel and doing more hammering. I think I can hold it in position while I solder it closed, and that'll be fine. It's very round, and I got the length just right, so I don't want to mess with it. Next, using the same mandrel, I'm going to bend a little bridge piece that's going to close up that joint. This piece will also end up being the boss where the hinge is mounted for the hatch, as you'll see. So I used the same mandrel. That curve will be close enough, even though it's technically on the outside of the piece and should be a slightly larger radius. With one end of the bridge piece clamped in place on the hoop, I drilled through for a rivet. This strap is riveted and silver soldered in place. If you're interested in this type of riveting and silver soldering construction, there's way more detail on how it's done in the boiler part of this video series, so start this playlist over from the beginning, and you'll see more of this riveting and soldering style construction than you probably ever wanted to. After cool down and cleanup, I then tapped it back onto the mandrel just to make sure that it's round. The soldering might have distorted it a little bit, so just tapping it back onto the mandrel will clean up any distortion that might be there. But in fact, it actually just pushed right on for the most part. Didn't need much correction at all, so that's a good thing. Nice and round. Look at that. The next piece is probably the trickiest on this whole assembly. There's a flange that goes around the base of this cylinder, and it has to sit at an angle. So watch how we're going to do this. It's a pretty interesting process. I'm going to start by scribing the inner and outer circles of the flange on this piece of scrap, which is actually the offcut from that other flange, so there's some kismet there. Then I'm going to set this up in the mill, and I'm going to drill out that center hole. I dug through all my hole saws and such, and the closest thing I could find without going over was this annular cutter. So it's not as large as I would like. I'm going to have to do a bunch of work with the boring head, but this will get me most of the way there. And annular cutters are really nice things. They are spendy, but compared to other large hole cutting devices, they're definitely my favorite. They do such a nice job, and they have really low tool pressure, unlike a hole saw, which is kind of a violent, messy thing. This next step will make a certain percentage of my commenters extremely happy. Here you go, boring head mafia. I'm cutting a big hole in the mill with the boring head. I'm not doing it on the lathe. Now, if you remember your conic sections from high school math, then you will know that I'm cutting a round circle here, but if this flange is going to sit at an angle, it actually has to be an ellipse. So I started by making it round and making a nice fit on the cylinder. That's looking really good. But then I'm going to have to take it over to the die filer and turn that into an ellipse in order to have this flange be able to sit at an angle on the outside of this cylinder. This I just did by trial and error. Just took a little bit at a time from the top and bottom areas of the circle, just kind of eyeballing an ellipse shape and just going very, very slowly until I had the angle right. After every few seconds on the die filer, I could test fit and I could see the angle gradually increasing on the piece, so I continued until it was correct. I'm also holding it up to the light as I go to make sure I'm not over-filing in any one spot on the circle. Once that was done, I drilled and tapped some tiny fixturing screws above and below the flange to hold it at that angle for soldering. This is a suggestion in the book, and it's a really good one that I probably wouldn't have thought of. It's very clever, as you can see. Very clever way to hold that piece at the correct angle. I then rough cut out the outside of that circle on the bandsaw, and now I'm ready to solder it in place. Everything gets pickled and fluxed and reinstalled with these fixturing screws. I pickled an extra piece of brass shim stock there because I have a feeling I'm going to need to do a little bit of gap filling. Some of my clearances didn't look great after my filing work, but we'll see how it goes. I'll silver solder the piece as is, and I've got the shim stock ready if needed. So over to the hearth with the solder. I'm heating mostly from the inside of the ring and a little bit from the underside of the flange, just always trying to heat from the far side of the joint from where the solder is sitting. That's always the way to get at the best joint if at all possible. Silver soldering on these small pieces is really satisfying because it's quite easy compared to the boiler stuff. They need so little heat because these pieces are such low mass compared to the boiler parts. I was ready to grab my filler material at this point, but you know what? That's looking pretty good. We'll clean it up and oh my goodness, look at that. I am shocked at how nice that joint came out. That is nicer than it had any right to be if you saw the clearances on my joints. The solder did run out of the seam in the cylinder there, but that's okay because that piece is going to get cut away anyway. So, wow, that couldn't have gone better. I'm now going to tap it back onto the mandrel to make it round again, a little bit of distortion there from the flange, and I'm going to turn that flange round using the original hammer forming mandrel. It's just held on there with friction, which is honestly plenty. These are light cuts, and it's a very tight fit on that mandrel. I've got an overall dimension that I'm aiming for, which is a little tricky to measure because the piece is at an angle. So I'm measuring from the front like this and just trying to find the widest part of the curve across the entire depth of the helix. All right, that should be it. That's looking pretty good. That flange is now round, and I can move on to the next step, which is to get those fixturing screws out of there. I did a combination of fret sawing and filing and other shenanigans to get rid of all residue and remnant of those fixturing screws, and also clean up any solder joints that needed it. Then finally I can fret saw off the lower half of the cylinder underneath the angled flange, because all of that needs to go away. My skill level with the fret saw is only moderate, so I didn't get too close to the flange just in case. I left quite a bit of excess material there. which I then cleaned up on the cheater machine, aka the belt sander. And finally finished that up with some filing. I don't trust the belt sander for real detail work. It's pretty aggressive, so I go to the file for the final finish. Ooh, say that 5 times fast. There we have it, one angled flanged cylinder piece that should be the correct angle to sit on the back of the tender and end up vertical. That's looking pretty good. Next on the agenda is the hinge, which I'm going to make from this piece of bar stock. These hinge pieces are very, very small. Some of the smallest pieces on the entire engine, I think, and not counting some of the pins and such. But I'm going to start by cutting out some little chunks out of the end of this piece of bar stock that I had lying on the bench. And I'm going to square these up on the mill and bring them to the final outermost dimensions of the hinge. But by the time we're done, virtually none of the material you currently see will still be there. I then set it up on end and center drill and drill all the way down the long way through this piece with a very small drill, and this is for the hinge pin. This is the trickiest thing because it's difficult to get a very small drill to track straight all the way down through a long piece, but lots and lots of peck drilling helps. The less work you make that drill do at once and the fewer chips you pack in that hole, the straighter the drill is going to track. Next, I set the piece up sideways and I mill halfway through this half of the piece, and this is going to form the screw flange of the hinge. Once I got down to final depth, you can see actually that the hinge hole is slightly off center on this piece, and that's not because the drill wandered, actually, it's because my end that the piece was sitting on isn't perfectly square. I decided this is probably close enough to still work, so I left it, but I can always remake this piece later if needed. These holes are supposed to be countersunk for flathead screws, but my smallest countersink still won't clear the edge of that hinge. I don't actually have the screws yet anyway, I need to order them, so I'll countersink those later by hand once I have the hardware in hand. The other half of the hinge is done the same way, except it has one additional step here at the end, which is that I set it up this way and I split it down the middle. This forms the outer legs of the hinge that wrap around the barrel of the inner piece of the hinge. These really tiny parts are the trickiest because in addition to being difficult to fixture, precision matters more. The smaller the piece is, the greater the percentage of a surface a given amount of error represents, so smaller errors matter more. Here's where we are so far with the two halves of the hinge pieces. You can see how they fit together, but of course they have to be round or they won't be able to swing through each other, so that's next. I considered various convoluted and fancy setups and fixtures to round the barrel parts of these hinges, but in the end, I just did it by hand. These pieces are so small that fixturing it would be so much work, and I'm not sure the result would be any better than careful filing. As I'm filing, I'm test fitting with the other half of the hinge and checking for clearance. Of course, the point of the rounding is not to make it look nice, it's to allow clearance so that the other piece can swing all the way around. On now to the lid of the fill hatch. This is a simple disc that I'm going to turn out of yet another offcut. I'm going to do this over on the lathe with a super glue mandrel. Got a scrap of aluminum in there, turned it down a little bit so it's smaller than my brass piece, face the front, and cut some grooves in there to aid with glue retention. And then some super glue on the piece, and I pin that in place, eyeball center with the tailstock, give it 10 minutes for that glue to set, and now I can center the piece up with the dial indicator using a dead center suspended with the center punch mark that was used to draw the circle. This ensures that we can true up the circle with minimal material removal and also makes sure that the final circle is concentric with my punch mark, because that punch mark is going to be a useful reference for future operations on the piece. Otherwise, concentricity wouldn't matter as long as you're removing more material than the runout in the piece. Then finally, a little bit of heat murders that super glue and gives us our part back. Next, we need a flat spot on one edge of the circle. Doesn't matter which edge because it's a circle, so it's only got one edge. And this is for clearance for the hinge to mount to. Now I'm going to set it up for some bolt holes using my pointer to center up on the punch mark. That's going to be a center reference on the piece, which is going to be helpful. I'm also going to edge find on this flat spot and use that as a second reference in the DRO because the hinge holes need to be referenced from the flat spot, but there's some other holes in this piece that are referenced from the center, so sometimes multiple references help on a part. When you weren't looking, I drilled 2 more holes at the bottom there for the grab iron that allows you to open and close the hatch. That little strap piece that closed up the cylinder now gets filed flat and becomes the mounting boss for the hinge. Tiny little holes get drilled and tapped. These were transferred from the hinge to make sure they line up. I did have to do a little massaging with a file to get that hinge piece to fit in there. Clearances are very tight. Now let's get the other half of the hinge, which is screwed on there. I also had to tune up that surface a little bit for clearance. And I'm going to use a drill as a temporary hinge pin. And let's see if the hinge actually functions. Here's the moving part that I was so excited about at the top of this video. Hooray! Look at that, it moves. It's a moving part. This is why we're here, to make things move. That tiny hinge was surprisingly tricky, I'm not going to lie, but I'm really pleased with how that turned out. There's not a lot of room for error, as you can see. Everything has to be in just the right place for that to function correctly and smoothly. And yes, I will shorten the screws on the inside of that, don't worry. Now for the bolt pattern in the flange. I spent some time trying to indicate this in on the mill, but the flange turned out not to be very round after the silver soldering. It got fairly distorted, and it was enough out of round that I couldn't indicate it in on the mill. So I'm going to do it old school. I drew a square on some paper, put an X through that square, and then I'm lining up the flange such that it's equidistant from the edges of that square, and the diagonal lines then tell me where to put my bolt holes. The flange is not out of round sufficiently that you can see it by eye, but it was out of range of the half-thou indicator, so dialing it in on the mill was just a fool's errand. Those little punch marks can now be drilled out for the mounting bolts. Alright, no more procrastinating. I'm going to have to put some big holes in my beautifully hand-filed top panel. Start with the big one, once again using my annular cutter, and then finishing this up with the boring head. Now if you're paying attention, you will know that this also has to be an ellipse because the vertical cylinder that meets this angled surface will create an elliptical profile. However, once again, we'll start with it round and open it up with filing later. Way less precision is needed here than the other elliptical hole because this is all going to be covered by the flange. As long as the opening looks reasonable from inside the hatch, then we're good. And this is why boring heads kind of suck. After every single pass, you got to undo all 3 locking screws on the little gib, and then you make your little adjustment, which isn't very accurate because the markings on that tiny dial are tiny, and then you tighten up the gib again, and then you make another pass, and each pass you're feeding down with the fiddly little fine feed clutch on the front of the mill, because this is a hobby shop and so we don't have powered down feed. Yeah. People who tell me I should do all this on the mill all the time, have you done much work with a boring head? Because it doesn't sound like it. Now that I've met my daily requirement of vitamin snark, let's test the hatch. That's looking good. Once again, the hole just needs to be smaller than the flange and not interfere with the bolt holes, and it'll be good. Now, the reason I did do this on the boring head is because then I can do these other holes in the same setup, which this piece needed. Everything was then done with one set of references, so that was nice. Now I can screw that back onto the tender, and I can get the hatch lined up and transfer the bolt holes for that flange. I'm not only making sure it's in the right position, but also that it's at the right rotation. If the hinge doesn't look square to the tender, or if the piece isn't sitting square, the hatch will be sitting at a funny angle because of the angled base cut, so the rotation of the hatch is very important. So I took some time, make sure that was really nice and straight, transferred those holes, drilled and tapped them over on the mill, and now I can screw this piece back in and see how it looks. I also made a proper hinge pin out of brass so I don't have to keep using that drill. Tried to make the hinge pin kind of a light friction fit so that the hatch will sit halfway open if needed. That'll just be more convenient and more pleasant to use and will also help keep it from rattling while the hatch is closed. Next up is the grab iron, which the drawings say to make from 12 gauge brass craft wire. That is easy enough to get unless you live where I do. I was not able to source it locally and I would have had to wait weeks to get it shipped. So I'm going to make some 12 gauge brass wire. I have this tiny brass bar and I'm going to turn it down to the diameter that I need. Here's a technique for turning very, very thin diameters over long distances. You work on it in sections and you do the full depth of cut all at once. That's the secret. You can't do multiple passes because the stock isn't rigid enough for that. But if you do one cut at full depth over short lengths close to the chuck, then you can get away with it. This works especially well with a collet chuck because each time you pull the stock out, you don't lose appreciable concentricity. With this technique, you can make very thin stock of infinite length effectively. I annealed that piece and then bent one end of it to 90 degrees, a little bit over length. Next, I can position it on the hatch and I'll figure out where to put the second bend. I'm lining up the edge of the pliers with where that radius needs to start to land on the second hole. The stock is plenty over length, so I don't have to get these bends in the correct place end to end. I just have to get them the right distance apart, which is not too difficult. I quite like the word grab iron. It's extremely literal in that way that British railroad terminology often is. I then soft soldered that handle in place, cut and filed off the excess, and here's the final grab iron. I'm very pleased with that. That's a lovely little detail, I think, and also functional. Underneath, I made this little tab piece now. I just cut and filed this by hand to fit into the trapezoidal slot. This is the tab that retains the bottom edge of that top panel. With that installed and everything cleaned up, I can now get the panel installed, and I'm going to put rivets on it. I want to carry the rivet pattern through this panel and try to make the panel look as invisible as possible. So I printed another copy of my rivet pattern that was used on the back of the tender, and I cut out the section that is where this panel needs to be. And then I did the old anneal, spray glue, and rivet embossing that you've seen lots of. Go watch the previous 2 videos in this series if you want to see more on that process. Now let's get this all finally assembled. I think we might be ready for some final glamour shots. Hatch installed, hatch functional. It's looking good. There's no slop in that hinge, and it has enough friction to stay partially open. Very pleased with that. Hopefully it won't rattle while underway. I didn't show you all my little mistakes in this assembly, but this was one of those days where I was just scrapping parts left and right. Some days everything goes perfectly, and some days I just seem to have to do everything twice. About half the pieces in this assembly had a practice piece. That's just how it goes sometimes. There it is, one tender water hatch. As you may have noticed, there's no seal or anything on this hatch. It doesn't need it. This tank doesn't need to be super incredibly watertight because it's sitting flat and level. The water's going to slosh around in there a little bit, but it's not going to leak much. If it leaks a little bit, I mean, it's a steam locomotive. First 3 rows will get wet. That's how they are. A viewer recently sent me something fun, an HO scale version of the Pennsylvania A3 switcher. It's really a very good little model. It's from the 70s, he said, and the detail on it is excellent. Looks like all the rivet patterns are pretty much correct. I didn't count them. I'm not one of those, but it looks like a very good model. It's kind of funny to see the size difference. Well, that's all I have for you right now. Thank you very much for watching. I hope you enjoyed this process. Thanks especially to my patrons for making all of this content possible, and I will see you next time.